Hi, Ross. Everybody say hi, Ross, on three. Ready? 1, 2, 3.
Hi, Ross.
Okay. These guys are a bunch of huge losers, and just get used to me calling them that. Just kidding. No, you guys are winners. Okay. All right. So we are going to record the class today for Ross, basically.
It's Ross. It's your favorite student, Cody. Hi.
That's right.
Okay. Get it out of your system. You got to the count of 5. 1, 2, 3, 4, 5. Not shut up. Okay. So, isosceles trapezoid, yes? Yes, isosceles trapezoid. There's a couple ways to make an isosceles trapezoid on here. I think you could do it if you used all of the outer circle, like that. Most people are probably going to choose to use the inner circle and the outer circle. That's what I saw favorite student number 7 right here have. I don't even know her name. She's the one that I always bully. Diana?
Oh, no, bullies them?
What's her name?
Diana.
Diana. Yeah, it's Diana. So
Number 7?
I prefer nicknames instead of real names. Okay, anyway, trapezoid, yes?
Yeah.
That's an isosceles trapezoid. Isosceles means that these two sides would be the same. Are all the opposite sides parallel?
No.
No, so I just don't check the box. Opposite sides are congruent.
No.
No, these two are, not these two. All sides are congruent.
No.
No. Opposite angles are congruent.
No.
No. All angles are right angles.
No.
No. Diagonals bisect each other.
No.
Let's check.
No.
This looks short. This looks long, yeah? So that's no.
I can't see.
That's because I don't want you to. How about that? Okay. Diagonals are perpendicular.
Yeah.
No.
Somebody's calling me. It's
No.
a random number.
Oh, yes. I do that all the time.
Gam number. Or whatever.
Okay, put your phone away, knucklehead. Hi, Ruby. Your hair is puffy today. You get an A. Okay. Do diagonals what are we doing? Diagonals are perpendicular, yes or no?
No.
No. Diagonals are congruent.
No.
Yes.
We have the diameter of the small circle and the piece from the small circle to the big circle. We have the diameter of the small circle and the piece from the small circle to the big circle. Are those diagonals the same?
Yes.
That's the only thing for a trapezoid out of all of it. 2 claps for you if you got it right. Ready? 1, 2. Okay, what's up? I'm unsure about the diagonals being perpendicular.
Not on all trapezoids.
I'm going to Google it while we're working on something else, and I'll let you know, cool? Because I don't know about that one. Most people are probably going to make a kite by doing something like this,
Yeah.
and then the other one will be down here. So let's run through the kite real quick. Opposite sides are parallel?
No.
No. Congruent?
No.
No. All sides are congruent?
No.
Opposite angles congruent? I don't think so. I think this angle up here is bigger than that angle down there.
Yeah.
All angles are right angles.
No.
Diagonals bisect each other.
No. That's not the same as that. No.
Is this the same? Are these two the same?
Yeah.
And are these two the same?
No.
No, so that's a no. Diagonals are perpendicular.
Yes.
Simone. Diagonals are congruent.
No.
No. Okay, that's a kite and a trapezoid. Test this Friday unless we work out something else together on that. So another piece of information for you guys. Down here at the bottom, I put some stuff for us for today. And so letting you know what's going to be happening to you, for you, whatever in the future. Let me make sure I started the video.
For real.
Your geometry mom is coming back on Friday. Okay, so we're going to do a little bit of vocab review, but first, stop it with the skateboard or I knock you out. Okay, today we have some geometry dad time. We're going to work on some stuff together today. That's going to be awesome. Then Friday, you're going to have your quadrilaterals test and a Mathia day. So my goal today is to teach you enough stuff. Chiva, pay attention. My goal is to teach you enough stuff that you will be able to do 5 workspaces in Mathia. And don't freak out, be like, oh my God, that's so much. It's not. Most of them are pretty short. There's one that's kind of long. I'm going to try and run through everything today to get you set up to be able to do that. it will be these 5 workspaces that you're working on Friday. You'll probably end up working on them on Monday a little bit as well. Cool? And then also we have some paper copies. I just basically stole problems from Matthew to give you guys to work on stuff in class together to make sure that everybody gets it, okay? Because Matthew is pretty good, but it's not perfect. Make sense in terms of the schedule?
Yeah.
Test is
Friday.
Friday. If you have questions, you need help or anything like that, let me know. I'm also going to send you out of here today with the practice test, because I know I gave you guys the practice test the other day, but I made copies and Palmer had already made copies, so I have extra copies, and so I might as well give it to you again. That way you have something to practice with. Make sense? Okay. And what do I need to Google? I need to Google if the diagonals of an isosceles trapezoid are perpendicular. I'll Google that in a minute. Let's go ahead and get onto the Matthew thing. So yesterday, we were working on problems like this, and I wanted to run through the vocabulary with you guys first. So what I'm going to ask you guys to do, while I Google if the diagonals of a isosceles trapezoid are perpendicular, look at the person next to you. If you need to pull out your notes, you can. Run through these vocabulary words and talk to each other about what they mean, and look at your examples in your notes if that's something you want to do.
All right.
Hi, Ross. Okay.
I just told you.
They're not perpendicular. Not all the time, anyway. Okay, you rocket scientists, let's go ahead and come back. Where the heck did my Matthew thing go? Okay. So I Googled it. The diagonals of an isosceles trapezoid can be perpendicular, but they don't have to be. So the answer for that one is going to be no. Cool? So we only had one box that we checked for isosceles trapezoid, yes?
Yeah.
What was it? The diagonals were congruent? Muy bien. Let's move on with our lives. The vocabulary that you guys are running through real quick. Complementary, how many degrees? Supplementary?
180.
Adjacent? Next to each other. The fancy way of that for adjacent angles is they share a vertex and they share a side, yes? Linear pair? They make a straight line. If they make a straight line, they are also, which one of these two? Supplementary. A straight line is supplementary, yes? Vertical angles. Everybody go like this. Vertical angles. Okay. It does look like an hourglass. Yes, just like that. Okay. So yesterday we were doing these, and I think we got to a place where we were pretty good at them. I just wanted to run through a couple of them today to make sure that we're feeling good about this. So take just a moment, stare at this. I'll ask you guys, I should have already said, let's take our notebooks out. So I'll say it now since I didn't already. Let's take our notebooks out. Where do we do math? On Mathia or on our notebook? In the notebook. We put answers in Mathia. We do math on the notebook. Okay. Let's go. Do you guys want to make sketches of these, or do you feel like you got enough yesterday? Got enough yesterday? Okay, we'll make sketches of the new workspaces after this, though. These angles, what type of angles do we have? Do we have, my list is gone, somebody erased it. Supplementary, complementary, adjacent, vertical, linear pair. What do we got?
Vertical.
Hallelujah. They see it. Praise the geometry gods. Don't worry about sketching this one because we're just going to run through it together as a quick review from yesterday. If you want to sketch it though, I'm not going to stop you. What's true about vertical angles? They're opposite of each other, yes. They are congruent, yes.
Yeah.
What does that mean about their angle measures?
The same.
They're the same. So is my equation going to have something like equals 180 over here on the right?
No.
No. What's my equation going to look like?
Equal.
4x equals 104. I'm able to see that right away, like I get it. I'm still a little bit confused and need more practice. I'm totally lost. Where are you guys at? Cool. Alrighty. So some people are still in the middle, that's okay. Hopefully we'll get good at this as we continue today. Divide both sides by 4, you guys know how to do that, yeah?
Yes.
X equals 26. You want to know how I did that in my head? You guys asked about that yesterday. What's close to 104? 100. 4 times 25 is 100. I need one more. That's 26. Okay. You asked a good question yesterday. You said you were feeling stuck here. Let's talk through this piece. What do I do with this 26 now? I substituted it into the 4x. And so my x value is 26. I can replace x with 26. And in Mathia, I can put the parentheses like that, or I can use the little star that's above the 8. And I'm going to get 104. It's pretty, we should have known it's going to be 104 already anyway, because those are vertical, so they're going to be equal. Let's just have Mathia solve this one for us and move on. We'll do one more as our little quick review here. Then we'll move on to the next content for today. So just a heads up, guys, the stuff for today is going to be all angle relationships stuff, and that's why I'm kind of loading it up to give it to you all at once to do these 5 workspaces, because it's really kind of the same thing, just repeated in a little bit different way. Let's take a look at this one. Complementary, supplementary, adjacent, vertical, linear pair. What would we classify these as? Turn and talk to the person next to you real quick. Where do these 2 angles go? Okay, that was fast. What are they?
Complementary.
Complementary. If you said supplementary, poke yourself in the eyes. Complementary comes before C comes before S in the alphabet. 90 comes before 180 when we count. These are complementary. Cool. Which means that they add up to make
90.
Okay. Remember yesterday when we talked about the equation, I said it's probably a good idea to put stuff on that side of the equation first. What's the number that would go on that side of the equation?
90.
Awesome. And what would we have on the left side? 4x plus 8x. We could solve that. Yeah, we'd have to, over here on the solver, say combine like terms and all that stuff. You guys are doing a good job remembering. Well done. Do we need to finish this, or do you feel like you would be able to kill this? This is no problem. Let's move on and do something else.
Let's move on.
Move on and do something else? Cool. Okay. So we are going to, Ross, I'm doing a bad job here because I told them we always make sketches, but I didn't make any sketches because I was just trying to review that real fast. So we're going to make sketches now of everything that we do. Okay, so have your notebooks ready. We're going to make sketches because we do math in the notebook. We put answers on Mathia. And where is Mathia? Where did I put it? Is it over here? It's over here. All right, we're gonna, if you guys can see, I'm gonna show you something. This one right here called Introduction to Triangle Sum and Exterior Angle Theorems. I'm gonna skip over that one for right now. We're gonna come down here to calculating and justifying angle measures and calculating angle measures. Then we're gonna jump back up to that one, okay? I might have to tell Palmer that she's gonna need to teach that one if I run out of time. This class always goes by super fast. You guys feel like this goes by fast?
Yes.
No. Yeah. Sure.
Bully. Okay. Sure, I like it. Okay, sure. Step-by-step example, we got the robot here with us. Basically with this, guys, we're doing the same thing that we've been doing before. We're just going to use some stuff to figure out how big these angles are. So since this is the step-by-step example, let's just run through this one. We'll make a sketch of the next one, okay? This is going to be us learning how to use this tool, all right? We're going to be given some information over here on these. If I was to sketch this in my notebook, I would record this information on the figure. So angle hug is congruent to angle beck. So HUG is congruent to BEC. Is this notation here feeling normal, like we do need to talk about this, or does that, like, we got it? Okay, cool. Angle GUE is 60 degrees. So I know that this angle right here is 60 degrees. All right? Don't worry about making a sketch and stuff of this one right now. We'll do sketches of the actual problems. Again, this is just me showing you how to use the tool. So we are asked to find the measure of angle BEC. That's the one we're looking for. So we know that hug, whenever I do these, I go through this process at the beginning and say, okay, what is everything that I know? And I make sure that I'm really clear on it. Hug is congruent to BEC. This is 60 degrees. We're asked to figure out BEC. What else do I see that I know that I can make a statement about?
Supplementary.
I heard someone say supplementary. Do we see supplementary angles here? Is this angle supplementary with another one?
No.
These two angles right here form a linear pair, yes?
Yeah.
Which means that they are supplementary. That may not be something that I need to help me figure out this problem, but I need to train your brains to be looking for everything that you can tell, all right? Are these two angles supplementary?
Yes.
This angle is 60. These two angles are supplementary. What does this angle have to be? 120. We were told that this angle and this angle were congruent. What does this angle have to be?
120.
See the process of reasoning that goes on here? We become investigators. We look for clues. We look for things that we can figure out, like, oh, I noticed that these make 180 because they are a linear pair. This is congruent to this, so this must be 120. The way that Matthew is going to handle this, you're going to say the measure, it's going to try and like walk you through the steps or whatever. I will usually do the math first and then fill out Matthew later. So the measure of GUE was given to us over here. It is 60 degrees, so we need to say in Matthew, the measure of GUE is given. It's either going to be given, we can calculate it, or it can't be calculated. It was given, and they told us that it was 60 degrees. Yes?
Yes.
What's going on here? Calculate the measure of HUG. It's given. Oh, shoot. Okay, I'm lost. I hate it when Matthew tries to take me through the steps because I don't think necessarily straight the way that they do. HUG, what did we figure out? It was 120. Was it given? Did we calculate it, or we couldn't figure it out? We calculated it. And we know that it was 120 degrees. We have to give a reason. There's not a drop down for the reasons. And so I have to be able to think of whatever the reason is. What was the reason? What did we call those two angles that made a straight line? A linear pair. And if I start typing it in there, a drop down menu will show up. You can see it better now. And I can click the thing from the drop down menu. Then I have to say which angles formed the linear pair. So it was GUB and HUG, right? HUG is the one that's on that list. And then it was GUB. HUG was linear pair with GU. Oh, they're calling it GUE, I bet, instead of GUB. Yep, there we go. So then we have to select this angle down here. So see that the Matthew is going through the exact same process that we did. It's just kind of a pain in the behind, yes? We calculated it. We knew that it was 120 degrees because we were told that it was congruent. So the reason that we can say that this one down here is 120 is because of the definition of congruent angles. If I just put in the word congruent and see how the definition of congruent angles popped up, I can select that. Then I have to say which angles have the same measure. What a pain. HUG and BEC. HUG and BEC are congruent, so they have the same measure. That's 120 degrees. Holy guacamole, huh? I'm not going to do all those steps in Mathia as we do this. I just wanted to demonstrate that. I'm going to have Mathia solve them for me. We're going to do these on paper. And then you would put your answers and stuff in Mathia, but I'm going to run you guys through these in our workbooks. So let's punch out a quick sketch. Z on top. We'll get our figure going over here. Does my sketch have to be like perfect and fancy and pretty?
No.
No, my sketch has to be quick. That's what a sketch is a fast drawing. Were we given some information over here?
Yeah.
Were we given some information?
Yeah.
Can't believe it's already 10:34. So that's flies. So we were given that UB bisects RUJ. So on my thing, I would say, okay, UB right here bisects RUJ. So I know that this angle and this angle are congruent. Yes?
Yeah.
Let's see what else we're given. Angle RUJ is 60 degrees. So RUJ is 60 degrees. It's kind of difficult to label that. But if these two are congruent, and this whole angle is 60 degrees, how much are each of these?
30.
So we can label 30 degrees. 30 degrees. What would be the reason why I can make that statement? Think for just a moment to yourself, okay, I said that that's 30 and 30. Talk to the person next to you. What's the reason I would put in the box to say, I can say that those are both 30 because, talk, go. I heard a lot of quiet people.
How do you know?
Like that. However, both three bisected two out of the two.
Cool. All right, let's come back. What would I put in the box on Mathia? I would put in bisect, and angle bisector would come up. I would click that. Make sense?
You're literally me right now.
What's that? Oh. So I can say that these are both 30, like I did in my sketch, because of the definition of an angle bisector. Yeah? So if those are both 30, what are we trying to figure out? We're trying to figure out RUZ. So RUZ, this large angle out here, what is a quality of this large angle that I notice when I think about its relationship to these other angles down here? I'm going to ask you guys to think about this for like 10 seconds or so and then talk to people around you. What relationship does RUZ have to these two angles down here? And is there something that I could use to help me figure out its measure? Go ahead and talk to people when you're ready to talk to people. If you don't know, say I don't know and just throw it at Schlegel or whatever. Ideas? Yes. Okay, so who had ideas? I had a partner over here. She did an awesome job. What were your thoughts? Go ahead. just speak. I'm not a person that calls on people to raise his hands. We just have class conversations. Go ahead. Speak. What do you guys think? People had their hands up. You can talk now. Just, I'm not going to call on you. Just say what you had to say.
No, I didn't.
Because RUB, or because I guess VB is a straight line. And the RUB equals 30 degrees. It has to be, it's a
Good call. So did people see that we have a straight line here? What's the fancy name for these two angles? Linear pair. These angles form a linear pair, which means that their measure is 180. So if this is 30 and these two together is 180, this has to be 150. Yes? Do we want to have discussion about that? Does that make sense? How are you guys feeling about it?
No, that makes sense. So that's what you said?
That angle has to be 150?
Yeah.
Is that making sense?
Yeah.
I'm going to, am I going too slow, too fast, or am I doing this just about right, guys? How am I doing?
About right.
Perfect.
Okay. Yeah, of course. So I'll run through that. Since I hear people still having discussion about this, I appreciate that. That's awesome. This is in geometry, you have to talk, okay? Because you just got to figure junk out. And the way to figure junk out is to talk about it with other people. So we knew that RUJ was given to us and that it was 60 degrees, yes? I hate the way that they label these because it looks like they're labeling just this angle here on the right as 60, but it's this whole thing. See how they put the arc all the way across?
Yep.
So then we were able to say, oh, since this line bisects this angle is going to be 30. We calculated it. It's 30. What was our reason for it? Bisect. Then we got to go through this whole stupid list. RUJ. And they could name it JUR also, right? So if you don't see the angle you're looking for, it might be that they just spun it around. So, because there's two ways to name angles. And it's bisected to form RUB and JUB. Or BUJ. Both of those are the same thing, yes?
Yes.
Then we said, okay, since this is 30 and this is 30, this angle right here and this big angle out here make a straight line. I got to say that this is 30. Crazy. There's a lot to fill in on this stupid thing. RUJ is bisected to form RUB and BUJ. All right. We said this 30 and this angle out here have to form a straight line, so they got to make 180. If this is 30, this has to be 150. Can be calculated 150. What's our reason? Linear pair. Cool. I'm not going to fill in the rest of that because I got better things to do with my life. So I'll leave that for you guys to do when you're doing the Mathia thing. Let's take a look at one more of these. So basically what I need you guys to understand through this process, let's go ahead and throw a sketch, is that you're using your deductive reasoning skills. This is not like regular math where it's like, hey, do the inverse operation to solve this equation, or hey, 5 plus 3 is 8. You got to think. You got to reason. You got to find the clues that you're given, and you got to use them to figure stuff out. So while I'm making my sketch and while you're making your sketch, be thinking about, hey, what am I given here? And what am I trying to figure out? And what relationships do I notice with these angles? And I'm going to see. So Ross, since you're watching this video, I'm just going to walk you through kind of my process and thinking in terms of how I'm setting this up to teach it. We're doing this Mathia junk. this is a mastery workspace, and so I'm getting random problems to do with students and show them how to use the tools and use this as an item bank to teach from. Then I'll have some paper that I stole problems from Mathia to put on that I can give them, so we have some actual in-class stuff that they do on paper after they do the workspace themselves on Mathia. So the processes that I'm trying to work through is teach it through Mathia, have students do Mathia, then do some paperwork in class, so I can actually see what they're doing. All right, Genius says we got a sketch.
Yes.
Cool. What information are we given?
Perpendicular IC.
Perpendicular. We see the sign, the symbol right here. It might be have been a while since we've seen it, but the perpendicular symbol is this. Yes.
Yeah.
So these are going to be kind of tricky. And again, there's nothing here that I'll be straight with you guys. Okay. There's nothing. My daughter is in 7th grade. There's nothing in this workspace that I wouldn't expect my daughter to be able to do. It's not hard. It's just a little puzzle. You just got to look at the pieces, see what you got. So IX bisects IC. Or not bisects, it's perpendicular to, where the heck is IX?
Top, straight.
IX is perpendicular to IC. Is this IC?
Yes.
So we have perpendicular lines there. I can mark it on my sketch. I'll just do it over here because it's bigger. IH is perpendicular to IZ. So IH is perpendicular to IZ. That's kind of a weird one to try and mark. And then the measure of XIH is 31. So XIH, this angle here, is 31 degrees. This one has a little trick to it. I'm gonna do an example using algebra really quick. Do these both equal 8?
Yeah.
What does this have to be?
3.
What does this have to be?
5.
So you can use both of these to figure out what's missing in the other one, yeah?
Yeah.
This is not the greatest example, but it'll work for us. One of the things we need to recognize is that these two angles make how much? 90. These two angles make how much?
90.
And they share this angle here in the middle. Yeah?
Yes.
Just, so let's run through this process real quick. If these two make 90, what does this one gotta be?
59.
59. And if these two make 90, what does this one have to be?
31.
30 what?
31.
31. 31 plus 59 is 90, yeah? There's a theorem we're going to do later in proofs that's called something like the, I can't even remember, but basically it says that if these two angles are the same, if these two angles, the 90 and the 90 are the same and they share this angle in the middle, that these angles out here are going to be congruent as well. So we were supposed to figure out CIZ. Did we figure out CIZ?
Yeah.
Do you want to run through the process of how to do that one more time? Or do you guys feel like you got it? We're just, this is not super, are you guys feeling like this is killer, or are you feeling like this is not too bad?
Not too bad.
Cool.
Yeah.
We'll do one more, then we'll jump over to our next workspace. There's a bunch here, huh? I know, huh? They give me a nice. All right. There's a bunch going on here. You guys want to throw a sketch real quick? Or do you want to not throw a sketch this time?
I think that's the same one.
Let's throw a sketch. Okay. I'll give you guys 30 seconds to throw a sketch.
I think that's the same one.
Oh. Matthew's a loser. It's the same one. Let's do one more. It is the same one. Oh, it's the same one because I hit solve it. I didn't go into the next one. Make sure you're paying attention even though you have a ball. Or I'll knock you out. So what Schlegel's going to do, for the sake of time, let's go ahead and throw a sketch real fast. I'm going to buzz through this one, and we're going to run through another workspace.
And it's not about that. Not about that. I know, not about that, but yeah, it's really only that. Any different test. That's running back well from the guy.
Bo Jackson's pretty good.
Only if you so. Only if you so.
Is the geometry dot doing okay today for you guys?
Yeah.
Making sense of this, Joe? Okay. Like the last one, I'm not going to fill in the boxes in Matthew because I just don't I don't care to spend my time doing that with you guys today. I got one more thing I got to run through with you. We are given that AG bisects QAZ, yeah? So AG, that's this ray over here, bisects QAZ. I don't know how big these angles are yet, but I do know that they're congruent, so I'm going to mark them as congruent. What's the reason for that?
Given.
Definition of bisect, yeah? What's going to pop up on Matthew is bisects. Angle whack is 60 degrees. So we're given that this one makes 60, this one is 60 degrees. We're constantly looking for relationships that we can prove either visually or with information that we were given. Let's just, for the sake of practicing it, do it. What do these three angles make?
180.
180. Does that help me?
Yes.
No, because I don't know what these two angles are. If I knew what one of these other ones was, I could figure out the third one. That doesn't help me, but I saw it, and that's the important piece for you guys right now is just to be seeing these things, all right? What do these two angles make?
180.
180. Could I find out how much this angle is?
Yeah.
That's 120, because the other one is 60. I don't even know what you notice I haven't even read the problem. I don't even know what they're asking me to do yet. I'm just looking at the figure and exploring what I can find or what I can prove, okay? It's a good habit in geometry to do that. If I know that these make what?
180.
180, what does this have to be?
60.
What's another reason why this has to be 60? These are vertical angles, and vertical angles are congruent. So there's two ways for me to get that this is 60. I can say, oh, I've got a linear pair here. I figured out that this was 120 because these made a linear pair. So I know that this has to be 60. These two are congruent. What does this have to be?
60.
Because of the definition of congruent.
60.
What does this one have to be?
60.
Got a bunch of 60-degree angles going on. It's crazy. They were asking us to find QAZ. We did a lot more than that. What is QAZ?
120.
120 because it's these two together, yeah? So just a straight up, what Schlegel's going to do when you see me doing problems like this, I'm not going to try to figure out what they're asking me to do at all. I'm just going to go and I'm going to attack it, see what I can prove visually, put the information down, and then guess what? I'm probably going to have the answer to the problem because I figured out everything about the figure. You see what I'm saying? So your job here is to be investigatory. You want to be curious. You want to look at the figure and go, oh, I know this, and so I can try to figure that out. Okay. So Ross, what would happen next if this was a normal day is I would say, hey, take out your Chromebooks to get on Matthew, you bunch of bozos, but I'm doing something different today because I'm trying to get Palmer set up to be able to do Matthew on Friday. So there is another workspace that I made a video for just recently because it's a new one. And my video took me 20 minutes. I'm going to try and get it done with you guys in the 9 minutes. We get out of here at 11 o'clock, is that correct? Not 11:05? Darn it. 11. So I got 8 minutes. I got 9 minutes to do what I did in 20 minutes in my video. So let's do it. When you guys start Matthew on Friday, you'll be solving for angle measures. The one that we just did is these two down here, calculating and justifying angle measures, and then calculating angle measures. The second one is the same exact stuff. We don't need to do any problems from it because it's exactly the same. You just don't have to put the reasons in there. So we're going to talk about this one because it's going to be the second workspace that you get to on Friday. It's this thing called the something, I don't even remember what it's called. This page is a bunch of hooey. We're just going to run through it super fast, okay? Can we go super fast right now? Is that all right? Okay, you guys have probably seen this demonstration done before where they cut the three corners off a triangle, they lay them out, it makes a straight line, everybody goes, yay, how incredible, right?
Yeah.
How many degrees in a triangle? 180, right? So they would form a straight line if we pulled them out. That makes 180 degrees. Angle A plus angle B, angle C. A triangle makes how many degrees? 180. We're going to fly through this page. The important things on the next one. If I was trying to find angle B, what would I have to subtract from 180? If I wanted this one, I would have to take this angle away and this angle away, yes? To figure out how much this angle is. So you'll just do this in math here. Bum, ba-dum, bum, bum, boom. Okay. If A was 40 and B was 35, that makes 75 altogether. How many more do I need? 105. I don't think we even need to do this, but I'm just running through it because I want you guys to be successful on Monday. So if we had a triangle that was x, 2x, and 84, what would those three angles add up to be? 180. So our equation would be x and two more x's is 3x plus 84 makes 180. Okay. And then we're just going to move on with our life. Okay. Let's talk about the next page. This is the one where we need to have some quick discussion. I got 7 minutes. You're going to take a sketch real quick, and we're going to just dialogue this. We need to be looking at this figure right here. Sketch this thing out. Take like 30 seconds to do it. Oh man, that's awful. I hate it when stuff like that happens. Move over here. Right here, Bailey. Is this better? We got a funky looking triangle, yeah? So what they've done on this triangle basically is they have extended the lines to go past the end of the triangle. This is called the exterior angle theorem. And it's a pretty easy one once you get it. But getting it is the tough piece, okay? Can I zoom in on this crap? I don't even know. Oh, yeah, I can. How about that? How about that? All right. I'm going to give you guys the short version. The long version is on the right side in Matthew there. They're going to ask you a bunch of stupid questions. You're going to be like, I don't care. And you're going to move on with your life, okay? This is going to be useful to us later, though. We're going to have 3 colors going on, red, green, and blue. So let's take a look at this triangle. Angle 1 plus angle 2 plus angle 3 makes?
180.
180. Let's do it one more time. Angle 1 plus angle 2 plus angle 3 makes?
180.
180, because that's the inside of a triangle, right? Okay, we're going to look for other relationships. Angle 6 and angle 1 make?
Perpendicular.
Not perpendicular, I say. What's this called? This is called a line. So we have a linear pair, yeah? So angle 6 and angle 1. I'm going to reorder them. Angle 1 plus angle 6. I'm going to do a different color too. Look what happened. What did I replace angle 2 and angle 3 with? 6. So angle 6 must be the same as angle 2 plus angle 3. You follow me?
Yeah.
Because if these 3 make 180, right there, and these 2 make 180, this must be the same as this plus this. Is that making sense?
Yeah.
All right. Killer. Let's do another one. Let's try angle 4. We know that angle 1 plus angle 2 plus angle 3 is 180. I'm going to rewrite that real quick. Angle 4 plus angle 3 makes
180.
a linear pair, so that's 180. I'm going to keep angle 3. What am I replacing angle 1 and angle 2 with? 4. What must angle 4 be the same as if it makes 180 when it's paired with angle 3? Angle 1 and angle 2. You follow me? Am I doing an okay job at this?
Yes.
Cool. Mr. Shadow's amazing. Oh my god. Okay, cool. All right. I don't need a huge amount of time to finish this thing up, but we are going to finish it up before we go. Don't move your notebooks. Don't do nothing. Last time, angle 1 plus angle 2 plus angle 3 is 180. If I had angle 5, what does it pair with to make 180? Angle 2 plus angle 5 is 180. What is angle 5? Remember, I'm keeping angle 2. Angle 5 must be the same as angle 3 and angle 1. So before you move your bodies or your notebooks or whatever, the exterior angle theorem is what this thing is called. You're going to do a workspace on it. Probably Friday is when you'll get to it. Angle 1 and angle 3 are the same as angle 5. When I add these two up, it's going to be the same as that. One more example, then we'll get out of here. Angle 2 and angle 1 are the same as angle 4. Here's what I need you to notice. This red angle, what angles am I including? The one that is adjacent to it or the ones that are opposite? Opposite. So angle 4 is the same as its opposite angles. One more. Angle 6 is going to be the same as, what are the opposite angles? 2 and 3. Today was rocking, everybody. Did we do all right? How about that? I'll even pause for the video. Okay. You guys are amazing. You're geniuses. Mathia should not be a difficult thing for you. I'm going to remind Palmer, and I'm going to bring candy for you if Palmer tells me on Monday that you reminded her that, where do you do math? In your notebooks, where do you put answers? On Mathia. So if Palmer tells me that you guys told her that tomorrow, Schlegel's going to bring candy. That's it for this video. Probably a little bit too fast on the exterior angle theorem, but time is always the enemy, right?